In this brief video, we're going to introduce the topic of logic, which is one of the branches of the philosophy of science that were introduced in the first video. For those of you who have not watched that or need a reminder, what is logic? Well, logic is essentially how we form arguments, or how we draw inferences. It's how we reason. There are three main types of logic that we can employ: deductive, inductive, and abductive. Within deductive logic, we generally begin with general statements which we refer to as premises and then examine them to reach specific logical conclusions. For example, all men are mortal, Socrates is a man, therefore Socrates is also mortal. The truth of the premises guarantees the truth of the conclusion. The form of argumentation is valid, as it is called by the logicians. Within inductive logic, we instead make broad generalizations from specific observations. The premises of an inductive logical argument indicates some degree of support rather than guarantee the truth or the validity of the statement or the conclusions being drawn. But within inductive logic, the conclusion is not guaranteed. So, for example, the premise of your argument may be that you've only ever seen white swans. Thus, you conclude, all swans are white. But it's not guaranteed from the structure of your argument that this is the case, as you've only ever seen white swans, and there might still be non-white swans out there. But, through what is called enumerative induction, you conclude that the probability is quite high that all swans are white, or at the very least, most swans are white. Abductive logic is slightly different from both of these. Instead, abductive reasoning starts with an incomplete set of observations and then proceeds to generate likely explanations for the observations. It involves forming a conclusion from what is known. So, for example, you might observe that the lawn is wet. But, you argue, if it rained last night, then of course the lawn would be wet. Therefore, there's reason to suspect it might have rained last night. But again, all this is a reasonable explanation for the potential for the observations that you've made. Other factors could have caused the lawn to be wet. Someone might have used the hose, it could be dew condensed from moisture in the air, and so on. But abductive logic is about drawing general or reasonable explanations for observations that you've made. Now, let's go through the general structure of each of these kinds of arguments in order. So, with deductive arguments, we have four key structures for them. Some of these are valid, and some of these are invalid. So, for example, we have what is known as modus ponens, and this is a valid form of argumentation. And I'll explain what I mean by valid in a moment. So, with modus ponens, the structure is as follows, and we'll use the example of a scientific theory here within our arguments. So, for example, if my scientific theory is a true description of the world, then we will observe a particular empirical observation. My scientific theory is a true description of the world, therefore we will observe a particular empirical observation. In this argument, what we're doing is we're making an assumption about, or we're stating a premise as to the truth of the scientific theory. If the theory is true, then we would have to observe certain things. We're then saying our theory is indeed true, and therefore we would observe those particular things. The structure of this argument is valid, given the premises. The conclusion, which is a therefore statement, would logically follow. However, this form of argumentation, whilst it's logically valid, isn't particularly useful for us in science. We never know whether our scientific theory is true. So whilst we could start with the premise, if my scientific theory were true, then we would observe a particular observation. We can't confirm the second premise, which is that the scientific theory is indeed true. So whilst it's logically valid, the argument is not necessarily sound. A sound argument is one which is valid in structure, so therefore the conclusions do logically follow from the premises, but also that we can confirm the truth of the premises, or at least we can have some high degree of confidence in the truth of the premises. Another form of valid deductive argument is what is called modus tollens. This one is slightly different, and in fact, much scientific testing comes using this type of deductive argument. Particularly when we've got established theories that make predictions. We use modus tollens to test those. So in this structure, it goes as follows. If my scientific theory is a true description of the world, then we will observe a particular empirical observation. So it starts with the same premise about the truth of the scientific theory, and that the scientific theory entails certain things should be observed. But we do not observe those particular empirical observations. Therefore, we can conclude that the scientific theory is not a true description of the world. This is what the philosopher Karl Popper suggested was the key logic to scientific research. That what we do is we start off with a theory, and our theory predicts that we should observe certain things. We then go out and conduct a study and see whether we observe them or not. If we observe them, we can't necessarily conclude that our theory is true. There could be other explanations for it. But if we don't observe them, then we can at least conclude our scientific theory is not true. The remaining two deductive arguments are invalid forms. So, for example, denying the antecedent. Within this one, we again start with the scientific theory being a true description and then from it postulate that certain empirical observations should occur. We then say that my scientific theory is not a true description of the world, therefore we will not observe a particular empirical observation. In this one, again, we can't know the status of the second premise, which is that the scientific theory is not a true description of the world. Affirming the consequent is another invalid form, and this is one which is actually quite common within science, although it is invalid. In this one, we start again with the same scientific theory being a true description of the world and that we will observe a particular empirical observation as our premise, but then we also observe a particular empirical observation, perhaps the one which our scientific theory predicts, and then from it we conclude that our scientific theory must be a true description of the world. But as we know, when we were considering modus tollens, we can't logically conclude that that is the case. We can logically conclude that if we do not observe what our theory predicts, that the theory is wrong, but we can't necessarily conclude that the theory is true just because we observe what it predicts, because there could be other potential explanations for why we observed the thing that we did. Modus tollens is the typical form of deductive argument that is employed in science, and it is one which is aimed at testing claims. That is the application of deductive logic when it comes to the scientific method. Inductive inference, as I said, is instead of focusing on testing claims or testing the propositions of theories, is instead focused on generalizing from empirical observations to either a generalized phenomena that we observe in the world or to some scientific theory about that generalized phenomena. So, thinking about the swan example, if we've only ever observed white swans, then we might conclude that white swans are the only ones which exist. The structure of inductive inference, therefore, is all particular empirical observations so far have matched the predictions of my scientific theory. Therefore, my scientific theory is probably a true description of the world. It might not be, but the more we gain particular empirical observations that our theory predicts, the more confident we become that our scientific theory may be true. Lastly, abductive inference uses the following kind of structure. As I said, it's aimed at generating explanations. Abductive inference is used generally in constructing the theories that we might then look to test using something like deductive logic. So it follows the following structure. We have the surprising fact, i.e. a phenomena or an event, that's supported by some particular empirical observation. But if a particular scientific theory were true, that is to say, if a particular explanation were true, then this surprising fact, this phenomena or observation, and the particular empirical observation that we've made would, of course, follow as a matter of course. Hence, there's reason to suspect the scientific theory might be a true description of the world. Abductive inference is used to generate candidate explanations that we can then go on to test. Either we might gain further observations that confirm it and inductively infer that there's a high probability our theory is true, or we might test it and find things that our theories or observe things that our theory does not predict, and therefore we reject it.